Good evening, friends. Now we are seeing numericals in module number 2 of fluid mechanics. So the velocity vector in the fluid flow is given by this equation. So this is the resultant velocity having the vector equation here. So it is asked to find the velocity and acceleration of the fluid particle at the coordinates 2 comma 1 comma 3 at the time t is equal to 1 unit. So it is maybe in seconds or minutes. So velocity components are u, v and w. So here u, so that is with respect to x component. So that is in x direction. So I can have this as u. So that is 4x cube. So it is the resultant velocity is given by the equation v is equal to ui plus vj plus wk. So using that I can write my u as 4x cube and v, so that is nothing but minus 10x square y. So this is vj. So v is minus 10x square y. Then wk. So w is 2t. So we have the velocity components uv and w. So for the given point having the coordinates 2 comma 1 comma 3, we have x is 2, y is 1, z is equal to 3 at time t is equal to 1. Velocity components at this given point. So u is now this 4x cube. Substituting x as 2. So getting 32 units. V. So minus 10x square y. Substituting x and y. So 40 units. W is 2t. 2 into 1. So that is 2 units. Velocity vector v at 2 comma 1 comma 3. So that is substituting u, v and w in the equation ui plus vj plus wk. Substituting the values of u, v, w. So writing velocity vector v. So 32i minus 40j plus 2k. Now resultant velocity square root of u square plus v square plus w square. Substituting u, v and w. So getting resultant velocity as 51.26 units. So that will be in meter per second. Acceleration. So ax, that is given as u into del u by del x plus v into del u by del y plus w into del u by del z plus del u by del t. Ay, u into del v by del x plus v into del v by del y plus w into del v by del z plus del v by del t. So partial derivation equations are written for acceleration components in x, y and z, ax, ay and az equations, acceleration equations. Now velocity components. We have now u, so that is 4x cube. U is equal to 4x cube. So velocity component, so that is del u by del x. From velocity component u, we have this partial derivative del u by del x. So 4x cube is differentiated, it becomes 12x square. So we don't have any y in u equation. So u is 4x cube. So if you differentiate u with respect to y, it is 0 now, and we don't have z also. So del u by del z is equal to 0. We don't have t in the equation. So del u by del t is also equal to 0. Now we have V. So V is minus 10x square y. So we have both x and y there. So differentiating V with respect to x and differentiating with respect to y. We have the derivatives like this, but we don't have z and t in the v equation. So del v by del z is 0, del v by del t is 0. Then del w. So we have w is 2t. We don't have x, y and z in w. So partial derivative of w with respect to x, y and z will be zeros. So my w is here 2t. W is equal to 2t. Differentiating w with respect to t is 2. So del w by del t is 2 into 1. So that is 2. Now substituting the x, y and z as 2, 1 and 3 at the time t is equal to 1. So in ax, ay and az equations. So in place of u, so that is 4x cube is written. And in place of del u by del x, 12x square is written. So like this, the complete acceleration equation is taken. So x, y and z values are and t values are substituted here. To simplify, we are getting ax as 1536 units. Similarly, ay. So we have u into del v by del x. In place of u, 4x cube. What is we have here? U is 4x cube. So that is substituted 4x cube. And in place of del v by del x here, so del v by del x is minus 20xy. So that is written. So like this, we have written ax, ay and az. We are getting of ax, ay and az. So acceleration, capital A, it is axi plus ayj plus azk. So this is vector equation of acceleration. So substituting ax, ay and az obtained here. Now resultant acceleration is square root of ax square plus ay square plus az square. So we are getting the resultant acceleration. This. Thank you, friends.